ready to dive into something totally different. Today, it's the world of programming.
Programming. A lot of people hit the brakes when they hear that. Sounds intimidating.
Right. But hold on, we're going beyond just the code itself, more like the why and the how it connects to our everyday thinking stuff.
Totally. It's not some secret genius club or anything. It's more about logic,
Yeah.
solving problems.
Yeah.
And yeah, even when computers mess up, which we'll get to, it's wild how this stuff applies outside of making apps and websites too.
Of computer fails.
Uh,
Now those I get. But before we air their dirty laundry, let's start basic. Imagine talking to a computer for the first time ever.
uh-huh.
What's the simplest program you could create just to be sure it's listening?
Gotta love those baby steps. Programmers often start with a little something called Hello World.
Hello, world. Sounds friendly enough.
It really is, like a signal. It's a program that just makes the computer say, well, you guessed it, a way to dip their toes in the water.
Okay, so not as easy as just typing hello world and crossing your fingers, I'm guessing.
You'd think, right? But that's where these things called programming languages come in. They're like translators between us and what the computer actually understands, which is way more jumbled.
So there are different ways to say hello world to a computer depending on its language.
Exactly, and some are way more straightforward than others. The book we're looking at, Think Like a Programmer by Allen Downey, uses this example to show how sleek Python is.
Python elegance, lay it on me.
Okay, so in Python, to get your hello world going, it's just this. Print hello world.
Short and sweet, I like it.
Right. Now compare that to another language. C gets a little more involved.
Let's see, the C+ version or
Buckle up. It goes. Hashtag include iostream.main, seeet.edgo.coro, hello world, std.endl, and finally.nade.
Wow, I'm already lost, like trying to order a coffee in a language I barely know.
Exactly. Python cuts to the chase, which is why a lot of people start there. Both programs do the same thing, but Python's like, why overthink it?
So it's all about breaking things down into smaller bites, even for computers.
That's programming in a nutshell. Just like, say, building with Legos. You start with these basic blocks, but combine them right, you get something amazing.
And I'm guessing sometimes those Lego creations don't go quite as planned.
Oh, tell me about it. Those are our bugs.
Yeah.
Downey talks about a bunch of them. Syntax errors, runtime errors, and the head scratchers, semantic errors.
Bugs, like digital critters messing things up.
Kinda, but it's more that we messed up the instructions. Syntax is like grammar and writing. Forget a comma, misspell something, the computer's like, whoa, hold up, I don't get it.
So one little typo can throw the whole thing off.
Right.
Computers are drama queens.
You said it. Then there are runtime errors. That's when we ask the computer to do something impossible, like divide by 0.
Asking for infinity, classic mistake.
Right. Computers can't handle that, things go haywire. And then the semantic errors. Those are the ones that make you feel like you need another coffee.
Okay, those sound like the real brain benders.
They're all about logic. The program might run fine, no crashing, but the result is just not what you wanted. Like following a recipe perfectly, but it still tastes wrong.
So it's doing something, just not the right something.
Sneaky. Exactly. Which proves a point: computers aren't perfect. They mess up if we mess up the instructions. We're the brains, supposedly.
Humbling, right. We put so much faith in tech, but it's only as good as we are. Speaking of which, what tools do programmers even use to give these super specific instructions?
Good question. Like any good craftsperson, they've got their go-tos. First up, variables. Think of them like containers.
Containers for what?
Information. You give it a name, stick something in it, a number, a word, whatever. Keeps things tidy, and you can reuse them.
So like the junk drawer, but organized.
Pretty much. Then there's expressions and operators. Expressions are like, well, expressions combining variables and values. Operators are the plus, minus, times, divided by signs, telling the computer what to do with all that.
NAF flashbacks. Okay, so far so good. But any curveballs, things that seem obvious to us, but trip computers up.
Oh, totally. Downey gives this great example. Commas in big numbers. Like, we write 1,000,000 makes it easier to read, right?
Makes sense to me.
Python's like, nope. Not getting it. Might think that comma is separating different things, not part of one big number. Chaos ensues.
Those darn commas causing trouble again. So it's those little details that can make or break a program.
Oh yeah, like forgetting one ingredient in a complex recipe throws everything off. But let's talk about something else important: conditional statements. It's the whole if this, then that logic we use all the time, even outside of programming.
Okay, yeah, like if it's raining, then I grab my umbrella. Got it.
Exactly. Gives programs their flexibility. And then for repeating stuff, we don't want to write the same code forever, right? That's where loops come in.
Loops, like circles.
Kinda, like those instructions. Lather, rinse, repeat. Loops let us do that with code, but way more powerful.
So, like, if I wanted to email 1,000 people, I wouldn't need 1,000 lines of code.
Nope. Loops to the rescue. And the crazy thing is, even super complex stuff, the apps we use every day, are built on these basics, variables, expressions, conditions, loops.
That's like realizing how a watch works, all those tiny gears doing their thing so we know what time it is. Amazing how something so intricate can be broken down like that.
And we're just getting started. Next up, we'll dive into how computers actually organize all this information they're working with data structures. Don't worry, it's way more interesting than it sounds.
Last time, we were cracking the code of how programmers talk to computers. Now, it's all about how computers actually make sense of all that info. Data structures, and no, it's not as boring as it sounds.
Not even close. Think about how you organize stuff in your life to-do lists. That bookshelf arranged just so. Maybe you're a spice rack alphabetizer, who knows?
Okay, full disclosure, my spice rack is more like a toss it in and hope for the best situation. But I get your point.
It's all data structures, right? Making info easy to find and use. Computers are the same way, just way more organized. And one of the biggies is the list.
Like grocery list, to-do list, that kind of list.
You got it. Downey describes it as an ordered bunch of items, like a numbered list, but with superpowers. Numbers, words, even other lists.
So if I needed to store, like, my grocery list in a program, I'd use a list.
Exactly. And the cool thing is you can mess with them, add stuff, remove it, reorder. Like a to-do list you can constantly rearrange.
Sounds like those people with the color-coded calendars, super organized.
Haha, yeah. And just like those calendars, there's a method to it. Lists are mutable, fancy word for they can change. And that's where things like aliases and cloning come in.
Okay, now you're speaking my language.
Yeah.
This is where it gets juicy.
So imagine a list called original list, got some stuff in it. You make another one called alias list, set it equal to the original. What you've got is basically a nickname, another way to refer to the same list.
So they're both pointing to the same thing, the computer's memory.
Two sides of the same coin. But here's the kicker. Change something in alias list, you change the original too, because they're linked.
Whoa, so it's like having two different names for the same document, edit one, the other changes two. That's risky.
Tell me about it. And that's where cloning comes in. That's making a totally separate copy. Like photocopying, scribble all over the copy, the original's fine.
So cloning is like the safe space to experiment without breaking everything.
You got it. And this whole alias versus cloning thing, it applies outside of programming too, you know?
Yeah.
Like sharing files. Sometimes you want someone to edit freely. Sometimes it's look but don't touch.
Mind blown. So lists, very useful, but got to use them right. Is there more to this data structure world, though?
Oh, we're just getting started. Lists are great for some things, but there are tons of others, each with its strengths.
Ooh, a data structure variety pack. What else is out there?
Well, Downey mentions stacks. They're last in, first out. Like think of a stack of dirty dishes.
The last one you add is the first one washed, a classic dishwashing dilemma.
Exactly. Then there are queues. Those are first in, first out, like a line at a store. Gotta be fair.
No cutting allowed.
And if we're really feeling adventurous, we've got trees. They branch out like a family tree, super efficient for certain tasks.
Sounds like choosing the right data structure is key to a program running smoothly.
Absolutely. Like using the right tool for the job. You wouldn't use a hammer to tighten a screw, right?
Unless it was a Monday. Okay, so we've got our coding basics. We can organize data with lists, stacks, queues, even trees. But let's be real, even with the best laid plans, sometimes bugs happen. So we've got our coding toolkit, ways to keep our digital ducks in a row, but like you said, bugs happen, even with the best of intentions.
It's the name of the game. And that's where debugging swoops in to save the day. It's not just about fixing stuff, it's about really understanding how your program ticks.
Debugging, so like calling the exterminator on those code critters.
Huh. I like that. But it's more like detective work, figuring out where things went off the rails, especially with those sneaky semantic errors where the logic seems sound, but the output's all wonky.
So we got to think like Sherlock Holmes, but for code. Magnifying glass on those semicolons.
You got it. Downey talks about forcing the machine, basically, really putting your program through the ringer to expose those hidden vulnerabilities.
Forcing the machine? Sounds kind of intense. What does that involve exactly?
Think of it like stress testing a bridge. You wouldn't just drive one car across and call it good, right?
Yeah.
You'd simulate traffic jams, crazy weather. You got to be sure it can handle anything.
So you're trying to break your own code on purpose. Talk about tough love.
Hey, got to be thorough. Anticipate those what-if scenarios, and one of the best ways to do that is surprisingly simple. Print statements.
Print statements, like telling the computer to show its work.
Exactly. Leave yourself a trail of breadcrumbs. By putting print statements at different spots, you can see what's happening with your variables step by step.
So if things go south, you can retrace your steps, see exactly where it all went wrong, like a map for your code. This has been quite a journey. We've gone from total programming newbies to, well, slightly less newbie-ish. But big picture, why should anyone care about this stuff if they're not, like, building the next big app?
Because it's about so much more than just code. It's about thinking logically, breaking down problems.
Hmm.
Those skills are useful no matter what you do.
So it's like training your brain to think differently.
Totally. Writing a report, planning a presentation, even organizing that chaotic spice rack of yours. These principles help you tackle things in a more structured way. Plus, programming is everywhere now, whether we realize it or not. Self-driving cars, medical discoveries. It's changing the world.
And speaking of mind-blowing,
Hmm.
Downey leaves us with a real thinker. Is there a problem that cannot be solved with an algorithm?
Right. Makes you wonder about the limits of what computers can actually do and what problems are just fundamentally human, I guess.
It's that kind of curiosity, that willingness to explore that makes these deep dives so fascinating. We don't always have the answers, but asking the questions is half the fun.
Couldn't have said it better myself. Programming or anything else. Stay curious, my friends. There's
Yeah.
always something new to learn.
And on that note, we'll wrap up this deep dive. Thanks for joining us. Until next time, keep those brains engaged and keep on exploring.